Hello student, today we are going to solve the questions of class 9th. Chapter is motion. The motion chapter is related to the motion of the object along the gravitational force and along the straight line. So we are going to solve the questions related to both type of motion. Question number 1 is a bus decrease A bus decreases its street speed from 80 km/h to 60 km/h in 5 seconds. Find the acceleration of the bus. In this question, we have to given two speed. First is 80 km/h and second is 60 km/h. Time is given 5 seconds. Find the acceleration of the bus. We know that the acceleration of we know that acceleration is the rate of change of velocity is acceleration. U is equal to 80 km/h and V equal to 60 km/h and time is equal to 5 seconds. These values are given here. Initial velocity, speed and final velocity. So we know that acceleration u a equal to v minus u upon t. Simply we use this formula to find the acceleration of the bus. Because bus is in decreasing the speed. Bus is decreasing the speed. So the acceleration will be negative. When we accelerate positively, the speed increase, and when the speed decrease, we find out the acceleration negative acceleration. It is called retardation. So we have to find the acceleration of the bus. We convert it meter per second because the value is given here second. When we convert kilometer per hour to meter per second, we multiply by 5 upon 18. 80 into 5 upon 18, 2 9s are 18, 2 4s are 10, 0. It will be 5 to the 10, 5 4s are 20. 200 upon 9, it is meter per second. Same way, we convert 60 km/h into meter per second. So we simply multiply by 5 upon 18 and find the result. That will be 5 3 is 15, 150 upon 9 meter per second. And this value, we have to find this value putting in this formula A equal to V. Final velocity is 150 upon 9 minus 200 upon 9 upon t. Time is 5 seconds upon 5. We solve it. It will be, because the denominator is same as it is 9, both sides, both points, both places. So 150 minus 200 upon 9 upon 5. We subtract 150 from 200, so we get 50 only. We subtract 150 from 200, we get 50, and the sign we apply minus, because 200 is negative and 150 is positive, upon 9 upon 5. Because minus 50 upon 9 in the ratio or fraction, what 5 is not fractionally, so we consider 1 upon 5 and multiply again. B multiply internally or externally. Internally we multiply 9 and 5, and externally we multiply, we have to multiply minus 50 into 1. So minus 50 into 1, that is minus 50, and 9 5 is the 45. We cut simply. We know that 9 5 5 times the 50, and 5 9 the 45. We find the result minus 10 by 9, and we again and we further divided 10 minus 10 by 9, we get the answer 9 is the 9, 1, we take a point and take 0, 9 is the 9, and further it is the result 1.1. It is meter per second square. In this type we solve the question number first. It will be our answer. We solving next question number second. Question number second is saying that a train starting from a railway station. A train starting from a railway station, and moving with the uniform acceleration attain a speed of 40 km per hour in 10 minutes. Find its acceleration. Next question is also in which we have to find the acceleration of the train. Here in this question, the train is going with a speed, attains a speed starting from its railway station, because the train is in the rest position. First, the train is in the rest position, so it will start and gain the velocity speed 40 kilometer per hour, because first firstly it is in its rest position, so we take u is equal to 0, because the train is stopped. Then it running v equal to 40 kilometer per hour, and its time is given 10 minutes. T equal to 10 minutes. We know that 1 minute equal to 60 seconds, and then we find 10 into 60 is equal to 600 seconds. Find its acceleration. We know that in the above question, we convert kilometer into meter per second, kilometer per hour into meter per second. We multiply it by 5 by 18. So here also we multiplied by 5 by 18 to convert 40 km per hour into meter per second. So we write here 40 into 5 upon 18, 9, 20, 20 5s are 2 5s are 10, and simply we take 0. Okay, 2 9s are 18, 2 2s are 4, and apply a 0 and 100 meter per second. It is initial initial velocity or initial speed of the train is 0, and final v equal to, we simply put in formula a equal to v minus u upon t. V is 100 meter per second and u is 0 upon t times 100 meter per second, 600 seconds is equal to 100 upon, we subtract 0 from any number, the result is same as the number. So simply we cut the zeros from this type of 1 by 6. We divide 1 by 6 here. We take, we have to take point because 1 is not divisible by 6. So we have to point and take a 0. 6 1 is 6. 6 6 is 36. It will next also repeated. The result is 1.6666, so on. So it will be, it can be written with two places of the decimal, 6.67, because it is repeated. Repeated form, it is more than 5. We take here 7 on the places of 6. So it is only, sorry, it is 0, 0 point, no, 1 6. It, 0.16, 0.16 meter per second is square. It is our second solution of this question. Next question is same. Question number third. A bus is starting from a rest. In this question also, a bus is starting from the rest position. So we take here initial velocity or u is equal to 0 from the rest with the uniform acceleration of 0.1 meter per second square for 2 minutes. Find number 1. We have to find speed required and the distance traveled in this period of time. solve this question. Let's solve this question number 3. A bus starting from rest. It is in the resting position. So initial velocity u is equal to 0 meter per second. With the moves with the uniform acceleration. Here acceleration is given. So we write here a is equal to 0.1 meter per second square. Okay. So next, for t, time is given 2 minutes. So we took here t is equal to 2 minutes and convert it into seconds. You know that 1 minute is equal to 60 seconds. So 2 minutes into 2 into 60 is equal to 2 6 is 12 120 seconds. Okay, we have to find speed, right? Speed required in time t. Here we can apply the first equation of the motion. We know the first equation of motion. First equation of motion is v equal to u plus at. We have to know the first equation of motion is v is equal to u plus at. Here v is final velocity or speed of any object, u is initial velocity or speed, and a is acceleration, and t is time. Simply we put the values u. We have to find out velocity, acquired velocity, speed in 2 minutes. So we apply u initial velocity or speed is 0. Acceleration is given 0.1 and t time is given 120 seconds. We multiply by, so we remove the point from here and cut a 0. 12 1s are 12, that will be 12 meter per second. Simple. First answer is find out. This type of question we can solve from the equation of the motion. So first, from the first equation we find the result, and in the second, the distance traveled. It is, we have to find the distance traveled. So we know that the second equation of motion is s equal to ut plus half at square. We remove this part because initial velocity is 0, then we multiplied by t, it's also 0. Because initial velocity is 0, when we multiply 0 by t or 112, sorry, 120 seconds, it will be, this part will be 0. So s equal to, we write only s equal to, in initial, when the initial velocity is 0, we write the formula s equal to 1 by 2 at square, and putting the value 1 by 2a, the acceleration is 0.1 into t is given 120 into 127. Simply we cut this 0 and remove the decimal. We cut 2 6 is 12 and solve. 12 6 is 72, and simply we put 0 here. This will be meter. In 120 seconds or 2 minutes, the distance covered by the bus will be 720 meters. Simple. Question number 4. Next question is 4. So we have to solve. Students, if you have any type of queries, you can ask your queries in the comment box. Please like and subscribe this channel and share so we got positive result from you. So question number 4 is saying a train is traveling at a speed of 90 km per hour. Brakes are applied. Brakes are applied so as to produce a uniform acceleration of negative acceleration is given 0.5 meter per second. Find how far the train will go before it is brought to rest. Hmm. The given value we write here, the train is traveling at a speed of 90 km per hour. Initial velocity is given because the train in the motion, so initial velocity is 90 km per hour. So in above questions, the initial velocity is 0. But here the situation is different. The situation is different and opposite. So we take u is equal to 90 km per hour. We know that when convert kilometer per hour into seconds, we simply multiply by 5 upon 18. 18 1 is 18, 18 5 is 90. 5 we multiply 5 5 is 20. The result is 5 meter per second. Okay. So next, and the acceleration is given a equal to minus 0.5 meter per second. It is called negative acceleration or retardation because the velocity is decreased. When velocity is increased, it is positive acceleration. When the velocity decrease, it is negative acceleration or retardation. So here we in this question we given that negative acceleration or retardation. How find the train will go before it's at rest? So while the final velocity v is equal to 0 in the rest position, and the time is not given here. The train is traveling at a speed of 90 is applied so as produce uniform acceleration. Brakes are applied. Find how far train will go before it. We have to find out the distance y the covered by train s equal to ut plus half at square. We cannot apply this formula because time is not given here. We know another formula, or that is third equation of motion. V square equal to u square plus 2as. From here we have to find out f. F is distance. In this question, the find out the train will how far or the distance covered by the train. So we apply this formula. Simply we put here 0 square U is 25 square plus 2. A is given minus 0.5 into S. We have to find out S. It is 0, 25. Square of 25, 25, 25. Square of 25, 25 into 25. 5, 5 is 25. 2, 3 is 6. In this, when we have to find out the square of any number in which unit place is 5, we multiply 5 into 5, 5 5 is 25, and we make one unit of tens place bigger than this place. So it is 2, we consider here 3 and multiply 2 3 is 6. It is the formula of Vedic Garit, Vedic math, एकाधिकेन पूर्णेन, एकाधिकेन पूर्णेन, एक अधिक करना है इधर और यहाँ पर पूर्णेन कंप्लीटली उसी से मल्टीप्लाई करना. So apply this formula, we can find the value 625. Multiply 2 5 is 10, or it will be negative. Simply we apply, because plus and minus will be minus. 2 5 is 10, 0, because decimal is one place. And we remove this minus 1s or s equal to 6 to 5. We take 625 from other side, so we apply negative sign. We cut here minus to minus. 1s or 1s s equal to 625 meter. It is the distance covered by the train in this period of time. The time is not given. When the train comes in the rest position, it will take the distance 625 meters. In this type, we solve four questions. Next two questions also need to solve. So we solve question number 5 and 6. Question number 5 is saying a trolley while going down in an inclined plane has an acceleration of 20 meters per second square. Trolley, inclined plane, inclined plane. Trolley is going in the inclined plane. Inclined plane. The trolley is passing through an inclined plane. This type of plane is in which the trolley is comes down. This is called inclined plane. It accelerates 2 centimeter per second. The acceleration is given in question 5. A is equal to 2 centimeter per second square. 2 centimeter per second square. We convert it into meter. B divided by 2 and we write here 0.02 meter per second. What will be its velocity? 3 seconds after the start. Time is given T equal to Here 3 seconds. Time is given 3 seconds. What will be its velocity? This question, in this question, we have to find final velocity equal to here to initial velocity, because in the rest position find velocity. We put the formula. First equation of motion is v equal to ut, no, v equal to u plus at. Okay, putting the value, initial velocity u is equal to 0, and acceleration is given 0.02 meter per second square, and time is given 3 seconds. We multiplied 3 to the 6, 0.06 meter, 3 to the 6. Okay, after starting, the initial velocity, sorry, actually, sorry, it will the it will get meter per second. It will get the velocity of 0.06 meter per second. Next question, question number 6. This type of question is very easy. You have to understand, and any type of queries you can ask in comment box. Question number 6 is saying a stone is thrown in the vertical upward direction with the velocity of 5 meter per second in the downward direction. So, a stone is thrown in the vertically upward direction with the velocity of 5 meter per second. In the downward direction, what will be the height attained by the stone? How much time it takes to reach there? In this question, the question is saying that a stone is thrown in the vertically upward direction with the velocity of 5 meter per second. Acceleration is given, sorry, initial velocity is given. U is equal to 5 meter per second. 5 meter per second. Because the stone is thrown in upward direction. The stone is thrown in the upward direction and it moves. Simply when it is in the peak point, final velocity will be 0. What will be the height of the tail? We have to find the height attained by the how much time and how much time it takes to the reach there, and time we have to find time taken and height attained. What will be the height that attained the stone and time taken, and time, what is the time? Two given values is here. From these values we solve the question. We have to find the time from the first equation of motion, we, because we cannot use here first equation of motion, because first equation of motion is need to solve time, acceleration or velocity. We have two values, initial velocity and final velocity. What we have not acceleration. Oh, yes, yes, yes. We have acceleration. It is gravitational because we, when we throw the stone or any object in the upward direction, it is goes under the gravitational acceleration. Its value is 9.8 meter per second square. We know know that g equal to 9.8 meter per second square. Simple, we can take it. It is 9.8 or 10 meter per second square. What we take here exact value 9.8 meter per second. Putting the uh, first equation of motion under gravity, it will be v equal to u plus, sorry, it is in the upward direction. V, the stone is thrown in the upward direction, the acceleration will be negative. So we took here the sign, negative sign, minus, not plus, because the stone is upward direction. In the upward direction, we take the gravitational acceleration negative. When we took here negative value, it will be negative. So we simply we use it v equal to u minus vt. In the place of acceleration a, we took here z. Putting the value, the given value, v is 0 and u is uh, 5 meter per second, minus g is 9.8 and t we have to find. We simply took here 10 meter per second also. Second square, sorry, because it is in 2 points position, 9.8 or zero point 0.2. So we can take, we may take here 10 meter per second or solid, no problem. It is, it will be negative from other side, goes 9.8 t, it is also negative and it will be negative after going other side. Okay, we cut minus to minus, and we have to find t. T is equal to 5 upon 9.8. We simply take here 10, but to then it will be, when we take here 10, it will be easier because the value is not given. So we take here 10, 10, so 10, 5 is a 5, 5 to the 10, 1 by 2 seconds or 0.5 seconds. T is equal to 0.5 seconds. In the upward direction, we find the height attained by the object. S equal to h equal to ut minus gt square. It is the second equation of motion. When we take the second equation of motion, f equal to ut plus at square, sorry, half at square, half gt square, half at square. So it is distance, or in this type of question, that distance is height and acceleration a is z, h height h and acceleration g. You're putting the value. Initial velocity is 5. Time we have to be find out 1 by 2 or 0.5 minus 1 upon 2. G is 10 and T is 0.5 and 0.5. 5 5 25, 2.5 minus 2 5 is 10, 5 5 is 25, 25 5 is 125. Decimal 1 2 1 2. B. Subtract 1.25 from 2.5. 1 point, sorry, D take rough work here, 2.5 and 1.25. B take a 0, carry B take carry from 5 and it will be 10, 10 minus 5, 5, 4, here remains 4, 4 minus 2, 2 point, 2 minus 1, 1, 1.25, 1.25 meter. So the stone attained the height 1.25 meter. Next question, question number 6. Question number 6 is saying, it is question 6. Yes, yes. We solve all the question. What next question, exercise question we have to find in this video.